Okay, we're going to talk about section 5.6 now, solving radical equations. So there are a number of ways that you can solve a radical equation, all right? And I'm going to show you all three. I'm going to show you how to do it algebraically. I'm going to show you how to do it graphically, and well, actually two graphical methods. And you can sort of pick your favorite method. You'll find, I think, that algebraically is honestly the fastest method and easiest to do. But you know, like I said, you can sort of pick for yourself what you want, what your favorite method is. So I'm trying to get the graph ready here to go. Okay. All right, so we'll deal with that graph in a second. All right, let's talk about the algebraic method. To solve this equation algebraically, what you're going to do is you're going to try to set, you're going to get the radical, the square root by itself. Then you're going to square both sides to undo the radical and then solve whatever is left over. So I can't square right now because if I do that, I'll have to square this entire left-hand side, which is something I'd have to FOIL. It would be an obnoxious mess. So I'm going to minus 4 from both sides first. And then I'm going to get this square root of x plus 2 is equal to 7 minus 4 is 3. And now that the radical is by itself, I can square both sides. So I'll square both sides. I'll get x plus 2 is equal to 9. And then subtract 2 from both sides to get x equals 7. Okay? So I don't think that method is too bad, but there's certainly places here where you could make mistakes in your work, right? Let's talk about the graphing method then. So one way to graph it, solve by graphing, and this will always work for any equation, is to graph each side and find their intersection. So if you graph each side, you're looking for their intersection. Okay. So what I've got here, turn on the projector mode, is I've got square root of x minus 2, and I should have left this as just plus 4, I'm sorry, plus 4. Okay, so there's that graph there. And then I've got y equals 7, so I'm going to graph the other side, y equals 7. And then I'm going to find the intersection. The intersection shows up here at I was going to say, I made a mistake in that. I'm like, sorry, this is not a very polished video here. Anyway, I made a typo when I typed it in. Anyway, so what you end up with is, solution is at x equals 7. Now you're looking for the x value here. I know they're both 7, but you're looking for the x. Okay, so x equals 7 is the answer there. All right. The other way to do this is to set everything equal to 0, and you're just going to have to kind of play around with each method because some problems it's going to be easier to set equal to each other to see the solution, to graph both sides, and there's going to be some problems where the graph is going to look nicer if you get it set equal to 0. So let's get this set equal to 0. That means move everything to one side. So minus 7, minus 7. So I get this, square root of x plus 2 plus 4 is equal to, sorry, that should be minus 3 is equal to 0. Okay, so there we have everything to one side, and what we're going to do in this case is we are going to graph just the left-hand side, and then we're going to find the x-intercept. Okay, so instead of plus 4, this would be minus 3. We will look for the x-intercept. It shows up here. So you can see x equals 7. So again, we got x equals 7. And then you might want to write up here that here you're looking for the x-intercepts. Okay, so any one of those methods is fine. I'm going to err on the side of the algebraic method. Okay, so we're going to solve this equation. 5 equals square root of x minus 2 minus 1. I'm going to solve it algebraically. I'm going to add 1 to both sides. I'll get 6 equals the square root of x minus 2. I'm going to square both sides. And I get 36 is equal to x minus 2. And then I'm going to add 2 to both sides. And I get x equals 38. All right, now one thing that you always want to do is you want to check for what's called extraneous solutions. So all that means is you're going to take your answer and plug it back into the original and make sure that you don't get a square root of a negative number when you plug it back in. That would be an extraneous solution, which is actually not a real solution. It just shows up in the algebra. So if I plug in 38, I get square root of 38 minus 2, which is square root of 36. It's totally fine. You can take the square root of 36. You're not taking the square root of a negative there. Okay, let's do this one. Now, we didn't talk about this a lot, but this 1/3 power is the same as the cubed root. So this equation can be written as 2 times the cubed root of 6x minus 3 minus 4 equals 0. Now, you can, this is already set equal to 0, so you could graph this and find the x-intercepts, and that would be fine. But I'm just going to show you how to do it algebraically here. So I'll add 4 to both sides. So I get 4 is equal to 2 cubed root of 6x minus 3. And then you're going to divide both sides by 2. Now, very common mistake here is to cube both sides right now to get rid of this cubed root. But you don't want to do that. You want to get the cubed root by itself first. So divide by 2. I get cubed root of 6x minus 3 equals 2. Now I can cube both sides. So on the right I'll get 8, so I'll get 6x minus 3 is equal to 8. And then I'm just going to solve this linear equation. So I'm going to add 3, I'll get 6x equals 11. And then divide by 6, so I get x equals 11 over 6. All right. And that's a number 2 that is not going to be a nice number when you graph it. So it's sort of nice to do the algebra because you can get the exact fraction here without the ugly decimal. All right, let's talk about solving inequalities. Now, solving inequalities with radicals is very similar to solving equations with one very, very important wrinkle. And that is this. This thing underneath the square root, it's called the radicand, that cannot be less than 0. We cannot, this inequality won't exist for whenever the thing underneath the root is less than 0. So the first thing that we do is we check when is, so this is step 1, I guess, when is 5x minus 10, that thing has to be greater than or equal to 0. It cannot be negative. So you solve this real quick, so we get 10 plus 10, so I get 5x is greater than or equal to 10, divided by 5, I get x is greater than or equal to 2. Okay. Now, I'm going to think about this in terms of a number line because it's a nice way to visualize this. All right, so what this tells me is that whatever my answer, it cannot be to the left of 2. It's got to be greater than 2. All right, so I'm just going to make a little note of that. Now, I'm going to actually go solve the inequality like I would as if it was an equation. So I'll minus 3. I'll get square root of 5x minus 10 is less than or equal to 5. I'm going to square both sides. I'll get 5x minus 10 is less than or equal to 25. I'm going to add 10 to both sides, so I get 5x is less than or equal to 35. I'm going to divide by 5. So I get x is less than or equal to 7. Okay, so now I know that x can be less than or equal to 7, so I'll put that on the number line. And okay, so what this tells me then is that my answers, my solution set, is between 2 and 7. Okay, so there's two ways that you can write this. One way is just the number line. So you can just shade between 2 and 7. You should have a solid dot here and a solid dot here. Way back when we solved linear inequalities, this is one way to represent the solution was a number line. The other thing that you can do is you can write this as an inequality. So this would be 2 less than or equal to x, which is less than or equal to 7. That just means between 2 and 7. So either one of these answers is fine. I kind of like the number line because it's visual. This is a little bit more concise, symbolic, okay? We should do one more of those. This is one you should give it a try and see how it goes and see if you end up with the same answer that I do. Okay, so pause, try it, and then hit play. All right, here we go. First thing we're going to do is check and make sure that that thing underneath the root, we want to know when that is greater than or equal to 0. Okay, so we solve this. We're going to minus 2 from both sides. I get 2x is greater than negative 2. I'll divide both sides by 2. I get x is greater than or equal to negative 2 divided by 2. That's negative 1. So on my number line, I'm just going to pay attention to this. This says x has to be greater than or equal to -1. So I'll put -1 on the number line here. All right, I'm just going to make a little arrow, kind of lightly, just to make a note. It's got to be greater than or equal to -1. Then I'm going to take and actually do the math, solve the inequality. So I'll subtract 1. I get 4 is less than or equal to square root of 2x plus 2. Square both sides. So I get 16 is less than or equal to 2x plus 2. Then I'm going to subtract 2. So I get 14 is less than or equal to 2x. Divide by 2. I get 7 is less than or equal to x. So on the number line, I'll put 7. It's got to be less than or equal to 7. It's got to be this way. And so there's my solutions. It's got to be between -1 and 7. So I'll just kind of shade that in. You can also write this as -1 is less than or equal to x, which is less than or equal to 7. That would be fine. A fine answer as well. Okay? So that's how you do inequalities. That's how you solve equations. You can always check these with the graph as well. Do it algebraically, put it in the graphing calculator real quick to check your answers, or vice versa. If you're doing it graphically and your answer seems weird, go ahead and try it algebraically and see how it goes. And that wraps up section 6 and wraps up chapter 5.